Okay, so for the exit ticket for this one, and I'll make it a little bit bigger so you can actually see, it says, looking at these two functions, which function has the greatest average rate of change in the interval of 1 to 3? Say what? So again, the very first thing that I want to do is graph it, because whenever I have a picture of a graph, it makes so much more sense. So I'm going to graph these two. Right? So let me turn all these off because this is what I was recording earlier today. Okay, so I have y equals 3 to the x, and then I have y equals to 3x squared. Right? And so right here, it kind of looks, oh, that looks pretty similar. But let me go home. Let me like center my graph. And then let me like look at it a little bit more. And if you remember, this is kind of like the tortoise and the hare. Remember the tortoise got that head start and then yeah, eventually caught up to, right? So this question's asking which has the greatest interval rate of change, sorry, the greatest average rate of change between 1 and 3. So this is a fancy way of saying between 1 and 3. Don't get mad at the notation there. They're just saying between 1 to 3. Okay, don't get confused on that. So between 1 and 3, yeah, so just between 1 and 3. So so you can restrict this domain by using curly braces like this. If you haven't learned how to do this, no worries. You just put a bunch of less than symbols in there, and then it cuts off. You'll see it right here. And then I'll say 1 less than x less than 3. And in all actuality, these are equal to signs. Less than or equal to signs, because this bracket means equal to. So let me just change those really quick. And it actually doesn't matter because, you know, the endpoint ends there. So they're asking who had a greater rate of change, 3 to the x, which is our blue guy, or 3x squared, which is our little black curve right there, right? So if I actually look at this, it looks like they begin and end in the same exact place. So the average rate of change for both of them is going to be the same. And so just to prove this, just so that you're on the same page as me, what I do is I plug in, I find the endpoints of what you're talking about. So I plugged in 1 and I got out 3 for both of them. I plugged in 3 and I got out 27. So since both of these are going to be the same, both of those rate of changes are going to be the same. So just so that we're all on the same page, we did 12 minus 3 divided by 3 minus 1, because remember, this is your slope, right? So y2 minus y1 over x2 minus x1. And so I got 9. Wait, did I do this? Oh, I did it. Why am I not plugging? This is supposed to be 27. Sorry. This is supposed to be 27. So we got 27. Let me see if I got this right. 27, take away 3, and 3 minus 1. Yeah, I did it right. Okay. So then here I get 24 divided by 2, which is just 12. So both of the rates of change are 12. And I knew this because when I graphed it, I saw that they began at the same place. They ended at the same place. So therefore, their rates of change, their average rate of change is going to be the same. Okay, I also checked that algebraically by plugging in my points. We did y2 minus y1 equals to x2 minus x1. Perfect. Okay. This one says, which function will have the greatest y value for very large x values? So this is that same question that we just answered. And so here, that means I want to know what happens all the way to the right. So I'm going to take off my restrictions right here. I'm going to take off my restrictions right here. Right? And I want to look at what happens all the way to the right. Right? And you should begin to see who actually wins. Who wins, blue or black? Who wins, blue or black? in the chat, please. Who wins, blue or black? Yeah. So because blue wins, right? Exactly. Because blue wins. And Miss Shelton, how do you know blue wins? Well, okay, it's kind of hard to see here, but let me, so can you pretend that this was a race and the race was 140 meters, right? Who got to the 140 meters first? And you're like, but Miss Shelton, they both got there. Yeah, but if this axis, the x-axis, if it was time, this guy got there in less than 5 seconds, and this guy got there less than 7 seconds. Do you see how blue won? Yeah. So blue, in this case, would be our y equals to 3x. Y equals to 3 to the x. That one has very large values, which makes sense because like when people describe stuff, they don't say, oh my gosh, it's been growing quadratically. They don't say that. They say, oh my gosh, that's growing exponentially. And actually, sometimes people don't describe that correctly. So that's always funny. Something that grows exponentially, a really easy example is like anything that goes viral, right? Like think about like a tweet that goes viral, right? A tweet that goes viral goes something like this, like I sent it to all of my followers, right? And let's say I have 10. Let's just have nice, easy numbers. And you guys are like, Johnson, you have no followers. That's right. No one cares about Miss Johnson. Okay. Then all of my followers send it to all of their followers. And let's just pretend, just for the sake of argument, everybody only has 10 followers. Okay. So then so my 10 followers send it to their 10 followers, and those people send it to their 10 followers, and so on. And pretty soon you'll notice that you're up to the millions on like the third or fourth or fifth or sixth, you know, in a very short cycle, right? And that's how things become viral, right? People share it with all their followers, and all their followers share it with their followers, and so on and so forth. Okay, so that is the exit ticket.